Dr. Murthy, in the previous video, you mentioned three of the most important AI solutions. You call them the three sisters of AI. Could you tell us more about the first one, regression?
So the first problem is called the regression. Essentially, what is regression? Let's say I have some data. Now, this could be age of the uh, people in my organization in the x-axis and salary in the y-axis. And these are like 50 employees in my organization. Each one's age I have taken and each one's salary I have taken, and I plotted. I'm an HR executive. I want to see how my employees are growing. I mean, financially, how they are getting better with more experience, more, as they get older. Now, this is good, but it doesn't give me an understanding of the trend in my organization. Now, regression is a problem where when I have data like this, regression is about finding the best fit that goes through the data. So in this case, this line happens to be the best fit that goes through the data. Now, why? What is the advantage of this? As you can clearly see, if I now give an age of any employee, a new employee, I can look up, substitute that employee's age in this equation, and I will get my his or her salary. See, this is a straight line, right? So most likely the equation will be salary is equal to age times some m, whatever that may be, plus some constant. Now a new employee age I substitute and I multiply with that m and I add that c, I get the salary. So regression is given the data, find the curve that fits the data best. In this case, it is a linear curve, but it need not be. Regression can also handle non-linear data. Here you see a line probably doesn't describe this really well, particularly this end. You see there is a lot of plateau and then it started rising. This may be something like experience versus the number of people reporting to the person, okay, in my company. Then for the first few years, the guy doesn't really add subordinates. They're at the executive level. At some point, they will start adding. So it grows slowly. Now, yeah, again, regression here is fitting that curve that fits the data well. Again, this equation here may be some quadratic or cubic, whatever that could be, exponential, but the concept is similar. When I now get a new data point, I fit it in that equation and I get the most likely answer, most likely predictor. Sorry, most likely target whatever I want to predict. This need not even be a one-dimensional problem. In fact, one-dimensional, you can visually solve it. It can be a multi-dimensional problem. So this is a 3D problem where I have two attributes this time. So I showed previously the salary as a function of age, but now let's say in reality there are other factors that determine the salary. One could be the educational background. Another one could be how many hours per day they spend in the office. More sincere guys will probably get promoted better and all that. So now I have age represented in one dimension, number of years of education represented in the other dimension, and then salary in the third dimension. Again, I can have a linear fit like this. Again, now I need to take age and number of years of education, substitute it in this equation. This time the equation will be y is equal to m1 x1 plus m2 x2 plus c. Again, I substitute, I get the y value. Again, this can be non-linear. This need not be linear. The behavior can be quite complicated. In real world, typically they are complicated. So As you can see, regression is about solving a bunch of problems where I know the values of certain attributes that are easy to measure: age, number of years of education, etc. And then I'm predicting another value of that particular record using these values. Okay, so I'm using age and income. I'm predicting the salary using age and income, and I'm predict age and the educational qualification. I'm predicting the number of people reporting to them. All these things, wherever I am predicting a number, a value. Okay, such problems are called regression problems, and it's a very, very important class of problems that artificial intelligence tries to solve.
Thank you, Dr. Murthy. I understand now what a powerful tool regression is for finding relations among data points, no matter the number of variables and the complexity of the relation.